Hello and welcome back to another June 1st Severe Weather Research Aerial Supercell Measurement System Design video. Today I'm going to be updating you on some of the progress that has been made over the past few weeks regarding the different aspects of the ASMS. So let's get right on into it. We have a fully prototyped out sensor package circuit where we have all of our sensors, the micro SD card reader writer that is writing down all of our data to a micro SD card, a LoRa transceiver module which transmits data every few seconds since it cannot keep up with the sensors while they're doing their thing, so that's why we have the micro SD card for full data, and then this is transmitting when it can. Since it's doing long-range transmission, it's hard to send large chunks of data very fast, so that's why it only transmits every few seconds, and we have the backup with the micro SD card. And of course, an LED to show us that we are indeed transmitting data, just a quick visual indication that it's transmitting data. We've also been doing some 3D printing as of late. On our left here we have the sensor package mount, which will hold our parachute, has a little slot for batteries that we can just simply tape over just to keep them in. And then on the other side we'll have our Arduino, and we'll just have some circuit card standoffs to hold the Arduino off with its PCB in front. And then secured around the edges will be foam just to protect it when it lands on the ground, because we don't want it just straight plastic hitting ground. When the parachute causes its descent, it won't necessarily be slow enough to protect everything, so we're doing a layer of foam around the outer edges just for added protection. And then we have a little open air cage here just to protect the antenna on this receiver. So this is the receiver that is going to be gathering data from our sensor package. It's just a simple Arduino with the LoRa transceiver, and you can plug it into a computer to see the serial output from incoming transmissions. So this is just a little cage that gets affixed on here just to protect the antenna, just in case if this gets dropped. Here's a quick look at our test circuit for the deployment system. So our deployment system is going to be triggered using these servos, basically in a Bombay style like you would see in a, like a B-17, like a World War II bomber, where two doors open up, allowing the sensor package to fall out. So instead there's going to be individual doors for each sensor package, which are going to be controlled by 6 servos, one for each door. So this is just one servo that we can quickly use to demonstrate that opening. So we have a switch on this transmitter side that is going to tell the receiver side to actuate the servo. So if I turn this switch, after a short delay, it'll actuate to the open position. And then we can close it so that the plane can land safely without a Bombay door open. Now this is just a simple test circuit to just prove the point of how we're going to control the Bombay of our deployment aircraft, or I should rather say deployment system. Now this is just a little simple switch that I could fit into a breadboard for demonstration purposes. There are going to be 6 switches controlling each individual trapdoor or deployment door, Bombay door, whatever you want to call it, on the aircraft. We're going to be using these toggle switches to actuate the door individually. So there's going to be 6 of these switches mounted onto a front panel on a what's called a bud box, that's going to contain all the circuitry, and we can label each door for each switch and then actuate them accordingly to deploy them in a coordinated manner. Now this was just a quick video going over the recent improvements that we've made. We're going to start construction of the aircraft in the next coming week, and we have just received the material for it, and we will be documenting the build process of that as we go along. We're also going to be implementing some final touches in terms of designing a PCB for our sensor package, starting to assemble that together, and then moving on to the actual unification of the entire system, and then beginning testing phases. So thank you for watching this episode, and stay tuned for future ones. Thank you.